Solving 5.5 homework. So question 1. Suppose that E and F are two events, and that probability of E 0.5, probability of F, considering that E already exists or is occurred, then we need to find what's the probability for E and F, so they both will be there. So it's going to be 0.5 because we have and, we multiply by each other. 0.5 times 0.3, considering they are independent. So 0.5 times 0.3 going to be 0.15. Next question. So what do we have here? Oh, permutation combination. All right, so in this case, what we're going to do, so let's see how we're going to figure out this answer. So we have ordered arrangement, okay, of R objects chosen from n distinct objects without repetition. When we are choosing R amount of elements out of total amount of n, and the order is important, let's say you are voting, I don't know, the director and then secretary and then this and that, and you have to go by order. Then we are going to use permutation. But let's say if out of, let's say, 25 people, I don't know, or maybe 35 people, you have the trainer gonna pick 20 people for the game. So it doesn't matter the order, right? Which whoever is good for game is gonna pick these 20 people. It doesn't matter who will be chosen first. In that case, we are going to use combination. So practically we are applying permutation or combination in a case when we have total amount of elements, n amount of elements, and we need to choose R elements out of this n. And when order is important, we use permutation. Order is not important, we use combination. Okay, checking. Good choice. Moving to question number 3. Let's see what we have here. So, is an arrangement R object chosen from n distinct objects without repetition and without regard to order. See, the without regard to order, that's already telling us it's a combination. Okay? Next question. So we need to find the value of factorial. To find the value of factorial, let me see, I can write here because it allowed me to write. Factorial 7. Hold on. I could write it here. What happened? Okay. I think pencil. Yeah, I don't need to go to pencil. Okay, let me see. I was able to, well, all right, I can use this way. So we have 7 factorial, right? 7, and factorial is gonna be, let me see, where is factorial? Here it is. And that is gonna be equal, it's gonna be 7 times 6, I'll explain, times 5 times 4 times 3 times 2, and at the end times 1. So you multiply and whatever result will come out. Okay? Equal sign. And that will be your answer for 7 factorial. So if you have 3 factorial, it's going to be 3 times 2 times 1. So from that number all the way, you multiply the sequence of all numbers. Do you need to multiply all numbers? What if you have 200? So can you imagine what will happen if you multiply all 200? Somebody will call 911 for you. So in such cases, let's say if we have factorial 200, all right, it's gonna be equal. You can do 200, let's say, times 199, okay, times, let's say, 198, and I can stop anytime I need to. 197, and keep in the format of factorial. So what you will have, 200 times 199 times 198, whatever gazillion big numbers you get, and then times 197 factorial. Okay, so let's move back here. Factorial 7, it's gonna be 7, so 7 times 6, we get 42, and then times 5, 42 times 5, we get 210, and then we multiply by 4, 210 times 4, it's going to be 840, and then times 3, it's 84 times 3, it's 2520, and then times 2, it's going to get 5040. So the answer is going to be here 5040. Good job. Moving to question number 5. Well, we have probability, we have permutation. The total is going to be 2 on this side, on the left side of permutation. With 2, it's a total amount, and 1 is selected amount. So we are choosing 1 out of 2. So let me show you how to use permutation using Statcrunch. Okay, let me put here. So what do we have? N. I don't know if I can get full number, full set, is equal to, and here I'm writing R, because R is selective amount, N is a total amount, okay? R is equal 1, okay? Next, what we are going to do, taking data, let me close. You click data. Well, this is need to be deleted. This is not gonna be. 1 second. I need to delete this. Okay. Now this one also let me delete. Yeah. Okay. So I placed N is equal 2, R is equal 1. So now I'm activating this cell where it's gonna go my result. So I'm clicking data, choosing compute, expression, and plugging here the function permutation, which is going to be PERM, permutation, and in parentheses I put 2. First I put total amount, which is 2, and then elective amount, which is 1. Closing and compute. Okay, new column was added. Let's close and see. There we go. Here is 2. See that? You have it 2 under permutation to 1. And the same way, I'm going to show you a combination. Let's say if I want to do combination, I will show this time, so I won't repeat every time. You already will know how to do it. So I'm closing. Okay, clicking data one more time. I choose compute and choose expression. And this time I'm choosing combination, where order is not important. COM, I believe B also has to be there, comma, let's say 2 total, and then 1 is what I'm selecting. And I'm clicking compute, Okay, closing. And there we go, combination also too. It's not always, it's not going to be the same, it just happened. You put some other number, let me do here different data. So to show you expression, let's say permutation, I'm going to pick permutation, parentheses 45, total, and out of 45, I'm choosing 4. Okay, combination of permutation of 4. Clicking compute, close. Here, how many I got combination? 3,575,880. That's going to be 3,575,880. Now I'm going to do combination data. Again, compute. And I'm choosing expression and put combination. B, it's going to be 45, comma 4, and click compute, close, and there we go, 135,751. This, so many choices you have. You choose combination or you choose permutation. As you can see, permutation allows much more choices than combination. Oh well, I have here 44. Okay, now wondering, let me see. I'll put comb one more time, COMB, parentheses for 45, comma 4, closing, same data. Why is it error? What's wrong? Again the same problem here. Syntax. Okay, closing. Here we go, 148,000. Let me clean this one because this was wrong one. I choose the wrong one. Okay, same permutation 45, 4 out of 45, and combination 4 out of 45. As you can see, permutation gives you much more options. Why? Because of formula. I'll write down 1 second. Let me choose. There. So the formula, let me use it. Formula for permutation. This is what we are selecting. This is total amount. It's n is equal. It's going to be n factorial over n minus r factorial. For combination, choosing r out of n is going to be n factorial r factorial times n minus r factorial. So because you have here also r factorial and it's a division, so you get less choices in combination versus permutation. Okay, so with your permission, I won't come back to Statcrunch. You already know in this the section how to work with permutation and combination, and you can choose it. So here we got 2. Let me plug 2. Fantastic. Moving to next question. So 6 out of 6. Okay. I'm going to put here 6 out of 6. I thought I won't come back, but... And that was what combination? No, permutation. Okay. Permutation. 6, comma 6. $720. Well done. And We are solving next one. Let me do this one also, and then if it's repeating, I won't do anymore. So combination 2 out of 10. Data, well, compute obviously, and then expression. So the other time my keyboard will come. COMB was 2 out of 6? Out of 10, okay. And B, so first come 10, comma 2. Okay. Again error, what is wrong here? Oh, this time 2 parentheses. Okay. 45, let's plug in. Bingo. Which means, let's see what is next question. Okay, you know how to do this one. Moving to number 9. Okay, you know how to do this one. Number 10. Okay, let's solve number 10. Let's see what we have for number 10. A woman has 6 skirts and 2 blouses. Assuming that they all match, how many different skirt and blouse combination we can have? So all of them are matching, so it's gonna participate and skirts and blouses, right? So what does that mean? How we gonna solve? Do you think we're gonna use every single element in here, or we just going to multiply by each other and get over it? What is your opinion? What do you think? Okay. If you are stuck, I'm going to solve it. So, since each one of them is participating, right? Meaning they are all matching. So you can wear any skirt with any blouse. That means we are not picking this or that. We just take and multiply by each other and get all combinations. 6 times 2, it's gonna be 12. Okay? Because it doesn't say selecting. It says they all match. How many different skirt and blouse combination? That's a keyword, match. If there wouldn't be match, then we should pick. It would be say something else. So we would figure it out. Number 11. All right. So what do we have here? Chosen from n distinct object without repetition and without regard to, I think this question is repeating, we did it, but it's combination. Okay. Well done. Moving to number 12. Oh, you know it's combination how to do it. Number 13. Okay. How many different simple random samples of size n can be obtained from the population whose size is 43? So we need to find out how many combinations of 5 we can get from 43. Okay? So what we're gonna do is get combination. It's gonna be combination 5 of 43. Let me put it here. Compute, it's going to be combination (43, 5). Compute. Again error. What is wrong? Oh, again. Okay. It didn't clear. One more attempt. Oh, it's easier to, okay, looks like it got it. All right. So 962,598. It's going to be 962,598. Well done. And that's it. I think we don't have anything else. Okie dokie. See you next